I am in charge of designing the image recognition model. This model needs to take an input image and output the exact card that is in the image. Our solution needs to be able to differentiate between 4 games, with each game having up to 42,000 distinct cards. In almost every image recognition model, the final output layer uses a pattern called one-hot encoding. This type of encoding is an array with length equal to the total number of distinct outputs. One thing that you need to know about neural networks is the size is not equal to each node in the layer. It's equal to the product of each node in each layer, because the weights of the edges are the values that you are training, which means our network size will quickly inflate over hundreds of millions of variables, larger than some of the most sophisticated image recognition models that currently exist. I need to figure out a way to decrease the number of variables so we could realistically train this network. I came up with a new network that I will use to pre-process the data and create new data labels using an autoencoder. An autoencoder is a network that consists of two subnetworks, an encoder and a decoder. The width of the input and output layers equal, and the width of the hidden layer shrinks and then expands to make an hourglass shape. The middle hidden layer is the smallest layer, and the values of the nodes of that layer can be used to represent an encoding of the input. Autoencoders are trained so that the network output will be identical to the input. The current iteration of our network takes in a 140 by 100 grayscale image for a total number of inputs of 14,000. The size of our encoding layer is 256. This means the network has an effective compression rate of 54 times. The format of the encoding is a floating point vector, which can be saved and trained against. This method is called unsupervised learning, and the reason this works is because the network is forced to learn 256 of the most distinct visual traits of the input image. This means that cards that will look similar will have a similar encoding, which is beneficial to us. For the image recognition network, the output layer width has been decreased from about 75,000 to 256. This makes the network feasible to train, and our problem has been solved. This solution is so incredibly elegant and efficient that I would do the exact same thing again. It's a perfect application of machine learning to process datasets so large it would never be able to be done by hand.